For the second part of section 1.4, now we're looking at yield quadratic formula. I've got Mr. Krabs there because I like saying formula. This over here actually is a weasel. I like to teach the quadratic formula to the tune of Pop Goes the Weasel, which some of you may have heard it. Remember, Pop Goes the Weasel is that whole thing. So you do need to know the quadratic formula. Hopefully you were told to memorize it at some point. If you weren't, now you have to. But again, we're going to go to the tune of Pop Goes the Weasel. I'm going to go real slow here. It goes x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula is your default. It will work all the time on a quadratic. Now, some students say, then why don't we just learn this? Well, students mess it up a lot. And we need to be able to factor things for higher level math problems as well. So we do need to know the other techniques. If it helps with quadratic formula problems, go ahead and write out the A, B, and C off to the side. Like for example, on number 1, A is 1, B is negative 10, and C is 22. And so then it just becomes a matter of plugging these into the formula. So x is equal to negative b. Well, it was already negative 10, so it's going to be 10 plus or minus the square root of b squared. So negative 10 squared is positive 100 minus 4ac. I'm just going to do this off to the side here. Minus 4ac. So that would be negative 4 times 1 times 22, which is negative 88, all over 2a. So 2 times 1, 2. From here, it's a matter of simplifying, and this is why we practice doing these kind of problems in previous lessons. Now remember, I can't just say, oh, the 10 and the 2 reduce. I want to first try to crunch down the radical, which root 12 you can simplify down into 2 root 3. Now I can do my heart reducing thing. 10 over 2 is 5. 2 root 3 over 2. The 2's would cancel, and I'd be left with root 3. Now, I could have done this problem with the completing the square that we talked about on the last lesson, but again, a lot of times students like to default to the quadratic formula, which is fine. For number 2, make some room here. Again, if you want to write them out, A is 1, B is 1, C is negative 1. Very small numbers, but if you were to look at this problem and go, oh, this looks like X method. Unfortunately, there are no 2 nice numbers that multiply to negative 1 and add to positive 1. So again, we're using the quadratic formula because these don't factor. Factoring would be faster, but unfortunately, they just do not factor. So negative b, so that's going to be negative 1, plus or minus the square root of b squared. So 1 squared is still 1. Again, off to the side, negative 4ac. Be careful here. So that's negative 4 times 1 times negative 1. So that's going to become positive 5. Oh, sorry, yep, positive 4, which in the end is going to become positive 5. Again, be careful of that. Sometimes students think that this has to always be a minus sign. Well, no. Negative times a negative becomes positive. And that's all over 2 times 1, which is 2. So I've got -1 plus or minus the square root of 5 all over 2. Square root of 5 does not break down at all. You can either leave it like this, that's fine with me, or if you still do the heart reducing, it's not going to change anything, but you could write it -1/2 plus or minus root 5 over 2. And again, that's if you're in the mode of heart reducing those things. On number 3, I've got some fractions on this, which makes it look a little nasty, but I can get rid of those fractions. A lot of times students don't like fractions, so what I'm going to do is I'm going to multiply by the least common denominator to clear out the fractions. The least common multiple of 3 and 2 is 6. So I'm going to multiply everybody by a 6. Now, you could go through this problem without doing that, but you'd have some fractions inside of square roots. It's going to get really ugly. If I do that, if I multiply by 6, that means the 3 and the 6 are reduced down to a 1 and a 2. So I have 2 times 2, so that's going to be 4x squared. 6 times -5, -30x. The 2 and the 6 reduces to a 1 and a 3, so that's going to be plus 3 equals 0. If I apply quadratic formula, again, this is just plugging stuff in, you're going to get 30 plus or minus the square root of, this is going to be 900 minus 48. If you do the b squared minus 4ac, all over 2 times a, which would be 8 in this case. So these are kind of bigger numbers than you'd probably see me giving you on a quiz or exam, but if I roll through this, it turns out 852 does actually factor tree. It'll turn into 30 plus or minus 2 root 213 all over 8. And if I reduce this, this is going to be 15 over 4 plus or minus. The 2 and the 8 would reduce down. I have root 213 over 4. So fairly gross numbers. Again, you probably won't see anything that big on a quiz or exam. For number 4, I got to move everything to the same side first. Again, this does not factor, so if I go to quadratic formula, you're going to end up with 6 plus or minus the square root of 36 minus 52 all over 2. This is the first time on these that we've seen a square root of a negative, but that's okay. That's the square root of -16. So this would become 6 plus or minus, well, the square root of -16 is 4i. Remember, square roots of negatives, we bring out that I. So this one I actually got rid of the square root, but we haven't, well, not really, because we still have the I in there. But if I do my heart reducing, 6 over 2, 3. 4i over 2, 2i. Being able to use the quadratic formula then leads us into perfect cubes. The general form for the factoring of 2 perfect cubes is shown here. So you've done difference of two squares. Like if I have x squared minus 4, you've done that factors into x plus 2x minus 2, something like that. If I have two cubes, it actually turns out that there's adding or subtracting them, sum or difference of two cubes. So it doesn't just have to be difference. And obviously it's going to be more complicated. This is how it factors. So a perfect cube, like a cubed or x cubed, a perfect cube like b cubed or 216. Now, with this general formula, a few notes. I'm kind of combining two things at once. This is saying that whatever the sign is here, you're going to keep the sign there. But this symbol, minus or plus, means you're going to flip the sign. So if it starts off as an addition, this is going to be addition, but this is going to be subtraction, and vice versa. So if it helps to go with your parent formula or your shell of this, the a for this problem would be x. The b for this problem is the cube root of 216, which is a nice number. It's 6. 6 times another 6 is 216. So now that I've got that, I'm going to use my general form here. So it says that it starts off factoring as the first thing, x. Since this was positive, it's going to stay positive. 6. And then it's going to be the first one squared, so that's going to be x squared. I'm going to switch the sign here, minus. Multiply them together, that's going to be 6x plus b squared, which is 6 squared, or 36. Remember, I'm trying to solve this first factor here. I can just use the zero factor property. The thing that makes that 0 is -6. But the hitch on this problem is all of this stuff, which I have to use quadratic formula on. So we're back to quadratic formula. This would be -b, so that's going to be +6, plus or minus the square root of b squared, 36. Off to the side if you need to, -4 times a times c. So that's going to give you, let's see, what is that? 128, I think. Oh, no, 144, excuse me. All over 2a. And so I'm going to start trying to crunch this down. So this will be 6 plus or minus the square root of -108 all over 2. Since you have the square root of a negative, you know there's going to be an I. 108 turns into 6 root 3. And again, we have that I on there. And finally, if I heart reduce, I get 3 plus or minus 3 root 3 I. So I actually get 3 answers to this. -6 is an answer. These are the other 2 answers over here. The last concept with 1.4 that we're going to look at is the discriminant. We've already kind of done the discriminant. We just didn't know we were doing it. The discriminant is just the b squared minus 4ac part. So it's basically the part that's underneath the radical in quadratic formula. Some rules with this: if the discriminant is positive, if you calculate b squared minus 4ac, and it's a perfect square, That means you're going to have two answers to the problem, and those answers are going to be nice rational numbers, meaning the square roots are going to be gone. If the b squared minus 4ac is positive, but it's not a perfect square, you're going to get two answers. They're going to be irrational answers. If the b squared minus 4ac equals 0, you're only going to get one answer to the problem. That answer is going to be rational. And finally, if you get a negative inside there, that means a negative in the square root, you're going to still get two answers, but they are going to be non-real complex answers, because you'd have the square root of a negative. So the first three cases, whether it's rational or irrational, these are all real numbers. So you're going to get real answers. The last case is where you'll get the non-real stuff. So on the last problems here, it's not asking us to solve. We just want to figure out what kinds of solutions. So we're just going to do the b squared minus 4ac. We're going to do the discriminant. So b squared would be 25 minus 4 times a times c. So that would be negative 4 times 2 times 5. So that's going to give me 40. So 25 minus 40, that's a negative number. So that falls into this category. So I know this is going to have two non-real complex answers. Basically, there's going to be an I in the answers. For letter B, I got to move stuff over first. So I have 2x squared minus an x minus 10. Do the discriminant again. So b squared, so that's going to be negative 1 squared, which is 1, minus 4ac. That's going to become positive 80. So that's 81. That is a perfect square, a positive perfect square. So this one is going to have two rational answers to it. All right, and that does it for the end of 1.4.